Hey, welcome back. I said 5 minutes, but whatever. It's gonna be starting up. So, next episode, we're gonna jump right in and get kind of the book checked out state machine created. We've got a lot of complexity in the book and reservation state machines. We've got those modeled up. I kind of wanted to start fresh, get us a new one, and focus on how we can do things like configuration and custom activities. So this episode is going to cover a couple new topics. We're going to start it off with a new state, and we're just going to jump right into it. So I'm going to add a new class called, let's just call it a checkout. Why not? Within the checkout, again, this is going to be a Saga state machine instance. So we will have, and I'm just going to steal some of this stuff from the book because it's all the same. Current state, correlation ID. We're probably going to need a book ID because if they've checked out a book, we're going to need to know which book it is. So we'll go ahead and put a book ID. We'll go ahead and put a timestamp of the date that it was checked out. So we'll just call this the checkout date. And I mean, I guess, wouldn't be a library without a due date, right? Gotta have a due date that the book is expected back. And that's going to be kind of where we're going to jump into here a little bit. So we now have to create the state machine for it. So let's just go ahead and do that fairly easily. We're going to call this the checkout state machine. Transit state machine with a checkout. And I am going to steal some of the code from the other one because why not? It's just so easy to steal code. I'll cut and paste these days. I'm going to get my little header here so I don't get my annoying little messages. And the only event we're going to look at so far is book checked out, because that's the only one we're going to observe at this point. And if I remember right, the book checked out event does include the book ID and the member ID. Great, that's awesome. Cool. So we are going to move this into another file, which of course means we have to go and cut this little header out so I don't get those little auto-fix warnings. So now we have this state machine, and the only event we're going to handle right now, at least initially, is the book checked out event. So again, we have to put our event declaration in here. Since it's by book ID, we don't have to define the event, but we do need our initially when book checked out, then and we will do things like context.instance checked out date equals context.data.timestamp, because that's when the book was checked out. And now we have to calculate the due date. Okay, so, semicolon, right, we're not an initializer. So contents.instance.due date. Due date is interesting because we have to calculate this. And this is something that we would typically want to have some sort of library default type configuration for. I mean, what is the standard checkout time? And if we look at our book checked out event again, it doesn't have any of that in there. It just says, hey, this book was checked out. So here is where we're going to want to have some type of configuration settings for our state machine, because we don't want to just hard code this in here because we know this is going to be something that's going to be configurable per library. So in that case, I'm going to create an interface because I love interfaces. And I'm going to call this my checkout settings. Why not? Sounds great. And in here, I'm going to put a time span of checkout duration. And this is going to be the length of time, because that's what duration means, a book is checked out for by default. Why not? Sounds super exciting. Now, this is something that we want to be able to put into this state machine because we're going to be setting that due date on here. Now, because it's a fixed duration, and it's just kind of a setting. We're going to start with that for now. When we get into using a service, we'll cover that as a custom activity that I'll do as the next step. But first I want to get this just basic stuff working so that we have the duration set up. So we're going to do our due date equals, but again, we have to inject this. So we have our checkout settings. We're just going to call it settings. And here we're just going to say settings.checkout duration. And we are going to have to copy this value because we're just going to add it. And there we go. So the due date is set. I don't think I had anything else on the checkout state. I had checkout date and due date. Oh, the book ID. I should probably copy that. So context.instance.bookid equals context.data.bookid. I need to know what the book is. Great. So that's going to create that. We're going to then transition to checked out. And we're good to go. This is going to be just our initial setup. This is how we're going to do it. We have our checkout settings. We're going to move that into a separate file. And now we're going to go create our first unit test for it. I'll start with the book state machine test because that was a pretty easy one. Pretty simple. And we'll create a new test class file here so that we have what we want. And I'll say when a book is checked out. And we aren't going to use the book state machine. We're going to use the, we're just going to call this the checkout state machine with the checkout data there. The event we're going to publish is book checked out. And we are going to have the book checked out. That's our event, right? Timestamp, member ID, book ID. We don't actually have an identifier for the actual checkout event. That's going to be something we're going to have to add to that contract because we're going to need a checkout ID. Grid checkout ID. Because we have to have it. We have to have a way to identify this checkout operation. And so we have checkout ID equals book ID. That's weird. Oh, because I did some search and replacing. That's why. So we have our book ID. We have to create a checkout ID. Checkout ID. This is going to be checkout ID. I don't actually think initializers are case sensitive, but I'm not going to test that right now. Here we're going to have checkout ID, comma, book ID equals book ID. We need a timestamp for when the book was checked out. And I think we need a member ID. And we're just going to create that as whatever for now. We can verify that book was checked out. We consumed it, that the Saga artist created an instance where correlation ID equals checkout ID. We can check that the machine goes into the checked out state. And again, checked out state here. I don't know why we do both, but I guess we did for fun. So we'll say when a book is checked out, we're going to go and rename this to the checkout state machine specs. And then we're going to run this. So running it, we should see, hopefully the test pass. We want to make sure that it creates an instance of our state machine. I have errors, never mind. Oh, because I already have a test called when a book is checked out. When a book is checked out, check out version. Great. I have errors now? Okay. Yeah. Starting to overlap my test names here. But I don't want to put a whole bunch of stuff into one test. I want to kind of separate these. Okay, great. Awesome. Look at this. I got a great error. Unable to resolve service for type state machine checkout settings. So my test clearly didn't run because I wasn't able to get the dependency for my state machine, which is the checkout state machine, which again, from earlier episodes, we created this little test fixture that does all this setup for us and adds these things to the collection. So one of the things we're going to have to add are those settings for that state machine. So to do that, within this test, I'm going to override the configure services method. if I can learn to type. And no, I'm going to override configure services. And in here, I'm going to say collection.add singleton of checkout settings, provider, new. And let's just create a simple class in here, test checkout settings, checkout settings, implement some members. Let's set our default duration to time span dot from days. Let's just say you get 14 days by default. And then we'll just do test checkout settings. Test checkout settings. And we don't even have to factory it up. Okay, so that'll add our settings, which should in theory make our test runnable now. Of course, it still failed to create a connector for checkout. The state machine was not properly configured. Book checked out was not specified. Book checked out was not specified. Oh, okay, we didn't declare the event because the event didn't previously have a correlation in it, which is now the checkout ID. And so now with that in there, we need to go to our message contracts, which again is this common file that we have where we're defining all of our, oh, interesting. So book checked out is specified, but we didn't specify it. Book checked out, and that was correlated by book ID, but we aren't using that, and it probably couldn't correlate by it. Interesting. Let's go see what is going on with this state machine. My guess is I'm going to have to declare this. Book checked out. I'm going to say x.correlate by ID, and that is going to be message.message.checkout ID. Now we should work. The instance state was not configured. Okay, I'm actually not even configuring my state machine right here. I'm feeling like a first-time student here. Yeah, oh yeah, see I've got all sorts of craziness going down here that I didn't copy over. So I have to have my instance state. The first instance that I'm going to have is checked out. There is no reserved state. I'm not using any of the, okay, so since I'm explicitly defining this using a different correlation ID than the default of book ID, I don't need to initialize the other message contracts. So it really doesn't matter. Okay, expected null, but was not null. Checkout state machine. So it was expecting to find one in the checked out state, but it didn't. And why is that? Because I'm looking for book ID instead of checkout ID. Actually look for the right thing, I might find it. Cut and paste can be painful sometimes, especially when it comes to unit tests. Okay, now we're great. We create our saga, we have the checkout, it's created, it was created in response to the book checked out event, and we used our dependency against that. The other thing that we want to check out is because we get this instance back, is we want to assert that instance dot due date is, in this case, we know we put in our test checkout settings of 14. Let's just take a timestamp. Just say date time now equals date time dot UTC now. And then we're going to produce that event, and then we're going to say due date is greater than or equal to now plus time span dot from days 14. And that should give us that should ensure that the actual due date is set correctly. So we actually asserted that the machine was in the correct state, it was in the checked out state, and the due date was actually set correctly. So now we're actually asserting that it did what it did, and it used the configuration to specify the checkout duration. So that's good. We're able to put settings into our state machine, as we can see in here. We're pulling that dependency in. We're correlating that event based on checkout ID to create the checkout. obviously we're going to want to do things like schedule some messages at some point. But the first thing I think we want to do is we want to add a custom activity that would theoretically do something like maybe look up the member and send them an email or something to say, hey, your book has been checked out, it is due, using that due date. So for this state machine, we are going to create a custom activity. Now, activities is kind of an overloaded term, and this is unfortunate. There are autonomous activities, and there are courier activities. Now, courier activities are for routing slips, and that's a completely different thing, but they're both called activities. So it's unfortunate naming, but it is what it is, and we just got to deal with it. So when we want to create an activity for a state machine, we have to make sure we're pulling interfaces from the autonomous namespace to do that. So I'm going to create a class that is going to be my, I'm just going to call this the notify member activity, because I don't want to go into like over naming things. And this is going to be an activity. You can see it's in the I pointed, how stupid am I? In the autonomous namespace. And the activity is going to be based off the instance type, which here is checkout. And I don't care about the event. There are two types. You can create activities that only reference the state machine instance, or you can create activities that reference the instance and a specific event. So if I wanted to also capture the book checked out event as part of this activity, I could create it using that extra interface as well. And I'll show both at some point. But for now, I'm just going to stick to the checkout because that's all I really care about at this point, even though I'm not copying the member ID, which is strange, but great. I should probably add that. Constants.instance.member ID equals context.data.member ID. So I'll add that member ID property to this, convert it to an auto property. That'll be right up here with book ID. Okay, now I'm copying that. Okay, so for an activity, it's going to have a couple of methods, and by a couple I mean 6. And what do all of these methods do? So here is where some of the information that, I don't know how well documented this is. It probably isn't. But I'm going to say, first let's create our filter. We're just going to do a create scope of notify member and do nothing else there. Except I think it's visitor.visit this. I think that's it. And that's to allow the state machine visualizer to actually get data from the state machine and say, okay, well, what is this? This is this type of activity, and so on and so forth. And just by visiting this, if this activity had other things inside of it, it could pass those around. You'll notice there's 2 execute methods and 2 faulted methods. And the reason there are 2 is because this is just an activity that relates to the state machine instance and not the event. So 2 different types of events. Events can be raised that don't have data. In this case, state machine events always have data for use with MassTransit, but there are other types of events that don't. And there's 2 different ones. One is a behavior context with data, and one is just a regular behavior context with the state machine instance only. Now, faulted is a different case. So the way this works is behaviors are built into essentially a list or a pipe. It's technically a pipe, but it's a chain of consecutive activities, and those are executed in order. So when execute is called, the first one is passed. If that first activity throws an exception, it jumps the track to the faulted side, which then calls the next activity on the faulted path. And the reason it does this is the way you define behaviors in the state machine is you could say they're all in order and they're called in order. Well, there is actually a .catch to catch exceptions, and that can be placed after, say, a particular activity like .then or .transition to or whatever. And so if any of those previous activities throw an exception, that .catch will grab that and can do things like put it back onto the execute track of another pipe or another behavior chain. So everything goes left to right, but once an exception is thrown by execute, it jumps the track and goes to faulted until faulted throws it back onto the execute path. So the chain is always in existence, but it can jump between the execute and faulted tracks. So that's how the behavior chaining works within the autonomous state machine activities. A lot to think about, but not really. So because this activity isn't going to do anything if there's a fault, it's just going to return next.faulted context and call it good. There's no fault handling here, so we're just going to return next. We have to call next because we have to keep the chain alive. Otherwise, it breaks everything. And the same thing for execute. We always have to call execute. We always have to call next with execute after we've done the things that we need to do. So because I don't care how the behavior gets called here, I'm going to create a common execute method that just does something. So I'm just going to call this task. I'm just going to call this task execute with the behavior context of checkout context. And that's just my own internal method. And it's going to do nothing. It's just going to return task.completed task. And within each of these methods, I'm going to await execute with the context. But again, as you can see, I've already screwed up. I have to add that await next.execute context. And I have to add that for both of those. And the reason I can't put that in a single method is because the next parameter is different depending upon which one it is. So I need to pass that correctly. This gives me the ability to also nest scope, very similar to how pipes work within green pipes. And it's actually built on the same chaining. Is when I call next.execute, I could actually modify that behavior context and pass something else to that next behavior. Because again, I'm always passing the input context to the next in the chain. So I could actually create a scoped context and do some crazy stuff there. And that's actually how some of the container things work. So I have a notify member activity. It doesn't do a lot here. All it's doing is basically nothing. I could put like a await context dot, or I could do like, I could do a console write line. I could do anything. I could, and I'll get to how I could make it a little bit better in a second. But I want to start simple first. So notify member activity, I'm going to put that into its own type. It isn't going to do anything for right now, but I'm going to add that to my state machine because when a book is checked out, I want to notify the member, and that's what this activity is going to do. So to add the activity to the state machine, I use the activity approach, and in this case, I'm going to say of instance type, because again, I'm just using that state machine instance, and I'm going to call this the notify member activity. And that is how you specify an activity within the state machine. And we only do it by type because we're expecting that type to be resolved from the container. It does support, if you aren't using a container and your activity only has a default constructor, it will just create an instance of that using activator create instance, so you don't have to worry about forcing a container to use this. But if there are dependencies, it will expect the container to be there for them. Why did that not mute? Excuse me, sorry about that. So now with this activity in there, and I don't really have a way to verify that it called it. I mean, I guess if I put a publish or something in there, I could do that. And maybe I should do that. Maybe I should put a publish in here. So maybe I should do something like, so first I have to get the consume context to publish, because again, autonomous is higher than MassTransit in the dependency chain, meaning it doesn't know anything about MassTransit. So a behavior context may contain a consume event context. And so here what we would do is just do a get payload, because autonomous is built on green pipes, so it has that in there. And we could just say consume event context of nothing. Oh, wait, no. Consume context, I think is what I need. Yeah. So I want to get the consume context because I want to publish something. Why not? And this is where I could actually take this as a dependency instead, but I'm not going to right here. And I could do something like await consume context dot publish. I'm just going to publish something like notify member due date or something like that. And I'm going to pass context dot instance dot member ID context dot instance dot due date. I can take this return completed status out. I'll have to create a contract for this because I haven't done that yet. But ideally, I would have some sort of service that's going to produce this message. And we're just going to call this the, what did I call that? The notify member due date. And we're just going to have a GUID of member ID. And we're just going to put a date time of due date. Because again, we aren't really trying to be super complicated here. We're just trying to put something out there. Notify member due date. Okay. We just want to publish something so that we can assert in the unit test that it was actually published, so we can verify that this activity actually ran. Hey, welcome, Nick, the first one, to the Twitch chat. So notify member due date. So within our notify member activity, we're going to publish that. We're going to go back to our unit test now for that state machine. And we are going to add an assert is true await test harness dot published dot any of notify member due date. We're going to put a little comment in here. Due date event not published, in case that part of the test fails, because there's like a million assertions in here already. I don't know if this is going to work. I'm going to run it and see what happens. Maybe we'll get lucky. A lot of code to write. And it passed. Okay. I always love when tests pass that quickly. Hey, look, we actually published our notify member due date event. So our activity got called, so everything worked. We got our consume context from the payload. We did a publish. That was way too easy. Or maybe I've just used MassTransit for way too many years. Some would say it's probably the latter, given the questions I get around some of the state machine stuff. So great, we added an activity. And the activity, because we're setting everything up within this test fixture to run from the container, was able to do that. If I wanted to change some dependencies, like let's say I wanted to take consume context as a dependency instead of actually doing this little janking around here, this is the preferred method, honestly, because again, it is chaining. So if anything has intercepted and actually change the payloads inside the behavior context so that like consume context is intercepted, it's definitely suggested that you actually do the get payload because it is part of MassTransit and it will be in that context payload. But again, there's other ways you could do it, and I could verify that for sure. I could come in here into the constructor of this and say that I depend upon consume context. And I could write that to a field, and I could just eliminate this line here, use the field, and verify that the unit test still runs. And it did, because again, consume context is resolvable by dependencies of any consumer or the consumer's dependencies, and state machine sagas are a form of consumer that's supported by any of the container support within MassTransit. So you can see that everything's still published and sent as expected. But again, for consume context, I tend to prefer to do it by getting it from the payload versus taking it as a dependency. So again, I would do it that way. But again, either way works. So that's how we create a custom activity and configure it on a state machine. Was there any other piece of that I wanted to cover? Let me look at my notes here. Big monitors are great when you only stream 1080p. It's like half of my screen vertical. It's pretty nice. So I got configuration settings. I did show So I did show how consume context can be a dependency on a state machine activity. Let's create one that actually has a real dependency. So like, let's say instead of just publishing a message here, let's say that we're actually using some sort of service. So let's go over into our library components and let's just create a new directory here. And this is completely arbitrary, but let's call this services for whatever reason we want to call it. Really, it's just a consumer, but let's just add a class interface and let's call it member registry or something like that. And this would have something like a task. I'm just going to say is member task bool is member valid. I mean, that's about as dumb as I can think about it. Is member valid. And we're going to pass the member ID. Ideally, I would want to like get an email address or something like that, but I'm trying to keep it super simple. Let's create a derived type of this of just call this the any member is valid member registry so that we can get and move forward here. And hey, guess what? We're going to return true. It's going to be awesome. It's always going to be true. And we'll change that to task.fromCompleted. Show you another nice writer feature. Replace with task.fromResult. So nice. I will fix my spelling error here. Any member is valid member registry. I'm just going to move that over here. Technically, this should be in my test project because I would never want to put this actually in production, but hey, it doesn't really matter. So let's go back to our state machine tests here, and let's go back to our activity. So our notify member activity, we're going to put that constructor back, and we're going to have the iMember registry now be a requirement of our activity. And within our execute, we are going to say, hey, wait, member registry dot is member valid context dot instance dot member ID. And if not is valid, we will do something like throw argument exception invalid member ID. That's right, arguments really like that, and that's going to do it. So we'll just say invalid operation exception. That sounds great. Invalid member ID. Awesome. Just something to throw an exception inside that activity, and that will set us up to try the catch stuff later. So now if we try to run that, we are going to get an error resolving that activity, and you'll see that that dependency isn't in the container yet. In fact, we'll get saga instance not found. And if we actually go down and look at the logs, we can actually see we received a fault inside the activity. Autonomous event execution exception. Yeah, I really wanted to zoom into that. Writer will go find anything that looks like a type, no matter where it is. It's so awesome when you click on stuff. The book checked out, event execution failed, unable to resolve service for type. Again, logging is absolutely fundamentally required when you're using MassTransit. Everything happens asynchronously on background threads. You're not going to be debugging these all the time, but the logs, you can see this is written out to the log as an error with a fault. Hey, guess what? Checkout failed. This is a bad thing. Fix it, and that'll get in there. And you can see right here, unable to resolve service for type. Most of the questions that get asked on MassTransit, it's like, hey, what does the log say? Oh, thanks, I figured it out from the logs. I mean, there's so many open closes on that. It's just crazy. So always configure logging. MassTransit supports iLogger factory of any type, whether it's .NET logging, Sirlog, anything. I use Sirlog for my unit tests, I think. I'm not sure. But always log, because that will get you 90% of the way there of finding any issues. So let me go back to my configure services for my test, because again, just like I put the singleton in here, I also need to add a service. And I'm going to do an add scoped, because scopes are always created for messages, and I want to be able to support that. So I'm going to put the member registry as a scoped service. Ideally, it really doesn't matter. What do we call this? The always is always. What did I call it? Dang it. Any member is valid registry. And that will give us that. Now, technically a registry, because there isn't any scope on it, would probably end up being a singleton. But again, I try not to force things into the singleton scope unless I really need to. So, and this could also just be transient. It really doesn't matter. But because consumers and activities are run within the context of a consumer, so there is a valid scope when they get executed. So now that I've added that, I should be able to see my unit test run. I should be able to see that the notify member due date is there, and everything is good. So that's how we can put dependencies on our activities as well. So I think that's enough for this episode. Hopefully this is useful. I don't think I've really covered custom activities very extensively in other videos, so hopefully this is a really useful one. Again, thanks for joining in. I'll push this commit up shortly, and this will be on YouTube, within an hour or so once it gets uploaded and converted. So thanks for joining. We'll catch you on the next one. Bye-bye.